Hello guys, welcome back to my YouTube channel Rahman Chemistry Coaching Academy. I am Dr. Tajur Rahman and this is our sixth lecture on stereochemistry. Today we will talk about an important topic that is double bond equivalent DBE. In our today lecture, we will try to learn about double bond equivalent DBE, the way how double bond equivalent DBE can be calculated from any given molecular formula of an organic compound. What information can double bond equivalent DBE provide us about an organic compound? So let's first we get start with the definition of double bond equivalent. What is double bond equivalent? The double bond equivalent can be defined as the double bonds of all kinds and the individual rings in a compound is known as double bond equivalent. The double bond equivalent is abbreviated as DBE. The double bond equivalent can help us, number one, in structure elucidation of an organic compound. Number two, to find out unsaturations and numbers of rings in an organic compound. Number third, to draw the numbers and structures, possible isomers of structural isomers of an organic compound. One thing should be noted that double bond equivalent DB can be used to find out the number of possible isomers, structural isomers of a compound and not the stereoisomers of a compound. The double bond equivalent is also known as level of unsaturation LU, degree of unsaturation DU, unsaturation index UI, index of hydrogen deficiency IHD, where double bond equivalent is equal to number of rings plus number of pi bonds in a compound. The double bond equivalent DBE can be calculated by various formulas. A total of 6 different formulas can be used to calculate double bond equivalent DBE of any given molecular formula of an organic compound. These formulas are, this is formula number 1, and this shows that double bond equivalent is equal to C minus H by 2 plus N by 2 plus 1, where C is the number of carbon atoms, H is the number of hydrogen atoms, N is the number of nitrogen atoms. This is formula number 2, and this formula number 2 indicate that double bond equivalent is equal to C plus 1 whole minus H plus X minus N by 2 whole, where C is the number of carbon atoms, H is the number of hydrogen atoms, X is the number of halogen atoms, and N is the number of nitrogen atoms. This is formula number 3, which shows that double bond equivalent is equal to number of carbon atoms minus number of monovalent atoms, mostly hydrogen atoms, divided by 2 plus number of trivalent atoms, mostly nitrogen atoms, divided by 2 plus 1. This is formula number 4, and this formula number 4 reveals that double bond equivalent is equal to summation n v minus 2 divided by 2 plus 1 whole, where n is the number of different atoms present in the compound and v is the valency of each atom. For a compound containing carbon, hydrogen, nitrogen, and oxygen atoms with general formula CaHbNCOD, the dB value can be calculated by using uh, this formula, that is double bond equivalent is equal to A plus 1 minus B minus C plus F whole divided by 2, where A is the number of carbon, B is the number of hydrogen, and C is the number of nitrogen, while D is the number of halogen atoms in the compound. This is formula number 5th, and to calculate dBE by using this formula number 5, first we have to calculate total number of hydrogen atoms by using this formula 2n plus 2, and if the given molecular formula contain nitrogen atom, then we use 2n plus 3 instead of 2n plus 2. Here in these both formulas, n indicate the number of carbon atoms. So to calculate the B value by using this formula number 5, first we have to calculate total number of hydrogen atoms by putting the value of carbon atoms in these formulas, and then these total number of hydrogen atoms are subtracted from the total number of hydrogen atoms given in the molecular formula for whom we are going to calculate dB values. The value of 10 is then divided by 2 to get dB value for the given molecular formula of an organic compound. This is formula number 6, and this formula number 6 shows that double bond equivalent in this case is equal to 2C plus 2 plus N minus H minus X whole divided by 2, where C is the number of carbon atoms, N is the number of nitrogen atoms, H is the number of hydrogen atoms, and X is the number of halogen atoms. One thing should be noted that the presence of sulfur or oxygen atom in given molecular formula have no influence on the dB value calculation because we ignore sulfur and oxygen atoms. Look at to this table. This table shows various molecular formulas and their double bond equivalent values. These dB values have been calculated by using the above mentioned 6 formulas. Now to explain how the dB values have been calculated by using these formula, let's start calculating dB values for molecular formula C3H6. This one. Now look at to these calculations. From the look of these calculations, we can notice that all the 6 dBs calculations formulas have been applied to calculate dB value per molecular formula C3H6. The dB value calculated per molecular formula C3H6 is 1. Here the same calculations have been exercised to calculate dB value per molecular formula C3H6O. By applying all the 6 dB values calculations formulas, the dB value calculated per C3H6O is again 1. The dB value can be calculated for compounds containing carbon, hydrogen, nitrogen, and oxygen, that is C7H15NO2 types of compounds, and C5H5N. These calculations again shows that all the 6 dB calculations formulas have been applied to calculate dB values for C7H15NO2 and C5H5N. The dB value calculated for C5H15NO2 is 1, while for C5H5N is 4. So this was all about how to calculate dB values from given molecular formulas. If you find my video interesting and informative, then please like, share, comment and subscribe my channel.